Hey Akshay,
Hey Vivek.
hey Akshay, am I live?
Yeah, Vivek, you are live. So it's great to have you with us today for the second day of Overseas Days. As always, it's great deal to have you here. So if you could just go ahead and give a small introduction about yourself and the session you'll be carrying out today.
Yep. Hey Akshay, thank you for having me today, and I hope everyone is enjoying the OSS days, and I know that it was an amazing first day, and there were very amazing sessions from very good community leaders. And I'm happy to kickstart day one today. Sorry, day two today. This um, is very interesting topics, and I just wanted to give a glimpse of how Kubernetes, how you can get started with Kubernetes, in fact. And it's Kubernetes is easy, only if you know how to get started with it, and what is the learning path, and how you should start learning from the beginners level to the advanced level. So that's the glimpse of my session, and I will be touching upon some of the core concepts and architecture, and also we will see how to deploy an application. And my good friend Karan will take it from there, and go into the advance on how to deploy it in production, kind of an area from a DevOps perspective, how to use how to do it from a CI/CD perspective, using GitHub Actions. That's the session introduction. Before I deep dive into the session, just want to introduce myself. I'm Vivek. I did a couple of software development work, and then I was part of DevOps teams in various companies, and I had my own startup. Then in helping the developers empower themselves and upskill themselves. Um, that's where I am today. So let us deep dive. And before I, even go in further with all the sessions and demos and other things, uh, I am assuming that person who is attending this session knows about containers, and is aware of containers, and is already know how to build and run containers. So everyone has this question, right? So what does Kubernetes do? So imagine you have 50 plus containers or 100 plus containers, and you are running it on different VMs, and there is production servers running, and there is an application, there is a request coming into these containers, and you are serving these requests. So it is very difficult to manage the request, to manage the infrastructure, etc. So, what does Kubernetes do? The main thing is to orchestrate containers. That's the basic thing about Kubernetes. And so you might have 15 VMs or 100 VMs and other VMs. So to manage these VMs, you need an abstraction layer. If the containers are running in these VMs, so Kubernetes provides an abstraction layer for this, and there is but it's nothing but a hardware abstraction. It provides an interface for you to interact with your VMs, and you actually define or you actually declare what state you want in these VMs, and how to access these VMs, and how these VMs can be utilized in a way that it has to be utilized, not underutilized by me. So uh, and also Kubernetes is it's a declarative tool. So what I mean by declarative tool is that as a user you declare what you want, you actually tell what you want, and Kubernetes figures it out how to do it. It's not kind of a thing like you go and do step by step. It is basically you are telling someone that, hey, this is what I want, and it goes and makes sure that the user defined set of object models are designed and deployed into the Kubernetes cluster. So, given the introduction to Kubernetes, what it does, it's a container, orchestrator. It is an abstractor for your hardware, and it's basically an engine where it makes sure that the user-defined declarative statements and user-desired statements, user-desired, object models is deployed into these systems. So I just want to give the architecture overview of it. So how exactly this communities work? So it's very similar to any model, right? Master slave model, client server model. So there is a master, there are worker nodes, and the master makes sure that it controls the execution, and worker nodes is more from executing the each individual jobs, individual task which has been assigned to it. So from a architecture perspective, from the way it works perspective, at the top you can see that there is something called as Kubernetes control. So it is nothing but a client. It is where you declare an YAML file. I'll show you how exactly it looks while doing a demo. So basically you will define set of statements, what you want the infrastructure to do, how do you want it, and how logically you want to how to build that logical separations into these in these master slave setup. So you are actually declaring it and handing it over to the master through a tool called kubectl. It's a client tool. You are going to install that kubectl onto your laptop, and you declare the statements in a YAML file, and you hand over that YAML file to the API server or through a kubectl command interface. And master, what it does is it's taking that there are a couple of different tools, services which is there at the master, that is control manager and the schedulers and the exits. Exit is nothing but a distributed distributed database, key pair value database. It's basically storing all the information about the cluster. So it is having the complete information about the cluster, where these containers are running, where these how many nodes, worker nodes are there, what is the state of these worker node, what is the load on these worker node. All the information is available at the exit. And the scheduler and the control manager works together. Scheduler is more from getting the job done. So basically control manager takes in the YAML file which user has defined, and then it tells the scheduler that, hey, this is the declaration from the user, and how can we execute this. And scheduler takes in the task and the job given by the control manager, and it creates a plan with the exit data which is there. And then it runs via the API server. It runs the same thing on the worker node. So what it is doing is, it is how many replicas you want, how many where it has to run these pods. I'll going to introduce pods later, but pods is nothing but a group of containers or a container. So on which worker node I need to run these pods, and how to manage these pods and other things. So, and control manager is basically very core, very important, and a very core of Kubernetes. It's basically a place where it actually maintains the network, the security, and the storage, you can also define your own definition for control manager. You can define your own definitions control in the controller declarative, and then use it with your object models, which is the YAML file, which is the declarative statements which you have. So via the API server, everything is talking to each other, and handing over the job to each other, and it is planning the execution. So the handover of the job happens on the worker node via kubelets. If you see here, there is on worker node there is a kubelet, and the kubelet is a simple binary which is responsible for making sure and running the pods, which is the running the containers. It is also keeping the information about the worker node. It is also giving the information back to the master node, what is the state of the worker node, etc. So there is so many information which is being transferred between these master node and worker node, so that it can maintain the state of what a user has defined in his declarative. um, and at the worker node, it is very simple. There is a container docker is running, and containers are running in an abstraction of pods. And then there is a kube proxy to access these worker nodes via internet. It is basically a control, DNS and other things, where it allows which pod to be accessed, which node to be accessed, and how to access and other stuff. So basically, the whole architecture is very simple to understand and very easy to do if you understand each and every component, what it exactly is doing. So to summarize, you declare the YAML, you declare what you want, and hand it over to master. And API server takes in and hand it over to control manager. Control manager reads the YAML and give the information to scheduler on what is required by the user, and scheduler checks the XSET and plans where it has to be scheduled and other things. And through an API server, it goes and talks to the kubelets, and kubelet schedules those pods or creates those pods, or does other activities like deployments and replica sets, which I'm going to give a overview later. But this is what at the high level, this is how communities work. And coming to the next is, so this is where very interesting, which I just wanted to give is, um, we are at the day one. I'm just talking about what a community story, it talks about. So this is something which was built by Brendan Burns. It's a learning path from day one to day 50, how you can um, learn communities and master communities from basics to advanced level. And I'm just picking things from Fifi Goes to the Zoo, right? So if you go back and go through these learning path, you can actually find very good videos series by Brendan Burns on Kubernetes basics, and he has given amazing video series there with lot of information on how exactly to use ingress, how to use deployments, how to use how to use the overall deployment and overall Kubernetes, how it works and everything, as is available in those video series. And go through this learning path, and you will be able to understand. It also helps the advanced people as well, because there is a lot of things which is there in terms of best practices at the end. And how to do a multi container applications, and building different kind CI/CD pipelines as well, which Karan is going to also talk about. And this is a link at the bow to access this learning path, and each of these learning path have the content available through that link itself. So go through that link, you will be able to go through this end to end, and you can learn communities in a better way. Okay, so just to give you a core concept, I was talking about pods. Pods are nothing but simple basic unit of deployment in Kubernetes. So basically it has certain containers, or it could be a single container. It is the way user defines in his object model. And namespaces is nothing but you have different services. So say service A, service B, service C, and through a Kubernetes cluster, you want to logically maintain the difference between service A, service B, and service C, and also the way the pods are running, right? So this pod belongs to namespace, which service this pod belongs to which service. So if you want to build a logical structure or partition your cluster in a way where you can identify these pods and these services and other things. That's where you will be using namespaces. And there is something called as services, which is nothing but a load balancer to access these pods. So it's very good explanation given by Burned Burns in those video series which I talked about on services, on how to use these services. And I'm sure Karan is going to talk about it as well in his talk. Um, I'm just picked this from the Fifi go to zoo, and this is how it is. The story. So if you go through that book, and there is good story there, and through the story they're explaining about different concepts about communities, which is really nice. But I've just taken a couple of things which will help you to understand this session and also the next session, which is there. So the replica sets are nothing but you can define how many identical pods you want to run in your nodes, right? I mean, you're only telling I need 10 or identical pods to be run on the nodes which is there. So the you can declare it in the object model itself. You can declare it in your declarative statement when you give. I'll show you where to declare it in the demo. And when you define it, the scheduler, the on the exec, using the exec, the scheduler and controller make sure that these many replications of a pod is running on the worker nodes. It doesn't mean that you are actually mentioning which worker node it has to run, because there is no point in doing that. This That means it will be an imperative, not a declarative tool, right? So declarative tool, you're just telling you want this many number of replications, and it is the responsibility of the communities to make sure that these many number of replications are running on different nodes. So the most important thing about this is, if one of the pod goes down, the kubectl, and which will inform the API server through, I mean, API server, and through API server it will inform the scheduler and control manager that this specific pod has gone down. And since the declaration makes, in declaration you have mentioned that these many number of replications has to be run, it will restart the replications. So this diagram actually talking about that one. If one pod goes down, there is one more pod getting created. So this is why community is so helpful, because it is a self-healing mechanism is being set here, right? So this is the replication set, and there is something called as daemon sets. Daemon sets are nothing but making sure a pod runs on all the nodes. There are cases, there are certain use cases where you want to make sure that a pod runs on each node, but in replication set you're not actually defining it. The scheduler defines it. It can be that in on the same node, it can have all of these pods replications are running, or on different nodes it is running, or on only on two nodes it is running if you have 10 nodes. But in daemon set, it makes sure that each pod is running, at least one pod is running on these different nodes. Okay. So and an example of that is as well, I just want to show, I just picked it from elastic, how elastic does metric beats. If you see the metric beats, right, there is there is only one metric beat pod is running on all the different nodes of the Kubernetes clusters. And this is actually getting the information about the node and sending it to elastic. But basically this is installed, deployed on each of these nodes. So you can use daemon sets in these kind of scenarios, right? Deployments are nothing but this is one of the amazing workload feature of Kubernetes, because it's nothing but how do you roll updates, and how do you do the rollbacks, and you know how you can manage the upgrade of your system. So there you are abstracting, replica, it is using replica sets at the bottom, but at the higher level it is called as deployments. It makes sure that you have version 1 set on 4 to 5 nodes and or on same node, but when version 2 is coming, it is actually killing each of those pods once the version 2 is loaded and works successfully. And even the version 1, it's not like it just just goes off. It's basically paused, or there's a cooling off period, so it cools off and then it dies. So that is the life cycle of pod, very nicely explained by Bandhan Burns in those videos. Go home and really get those videos done. I'm sure that is something which is very very interesting in terms of how you can deploy these pods. Okay, so given that, I just want to go into the demo because I don't want to waste time. So I've already got myself a Kubernetes cluster on Azure Kubernetes service, so on the Azure portal. So let me show you how to do that as well. I just want to, this is the portal, and once you log in, you can see the portal, and I'll just go ahead and create a resource. And then while I create a resource, there is something called as Kubernetes service. And when you click on Kubernetes service, there is you can open up the Kubernetes cluster creation tab. So it's very simple. It's there is a if you go and click here portal menu, and you just click on create a resource, and you'll be able to create new services. There's our favorites and a couple of things which you can make changes. If you don't have a group, you can create one, and you can create one now. This is the resource group, and you can give a name, test cube, and you can give a name, and you can use whichever region you want to deploy this. I'm keeping it as central, and you can make changes to the node sizes. It's basically a size, and also the when I say node sizes, it's nothing but a work on nodes. This is 3, but you can make it as how much ever you want. I'm just giving the number which I want to do for the test. There is something called as node pool, that even if you have declared, for different kind of workloads, if there is a scale scenario and you are running out of your nodes which is there, and you want to add a couple of nodes, you can do that. And there is enable virtual nodes is there. This is a little bit of in a burst scenarios, and how to use it in a serverless container instance service. That's something which very interesting talk there. You take a look at it, and there is an authentication which is there. Basically, there are a couple of authentication methods and other things, and there is network. If you can use kubenet or Azure CNI as well is available, which is part of the container network interface. And you can either use the standard load balancing, and there is HTTP routing as well. You can select all those required information for you to do the network within within the cluster, and external to the cluster as well. And then there is Azure container service you can integrate with, container registry service, in fact, so where you are going to store all your containers and use it. And then you can do a monitoring and other things which is required, and just create a new cluster. So I've already created a new cluster, and I just want to go through the what application I'm going to deploy. This is the object model which I was talking about, and this is nothing but a declarative statement written in YAML for deploying an application. So this is a couple of couple of things, couple of information which I'm telling to the Kubernetes master, that this is what, and this is how I am looking at this cluster to behave, and this cluster to work. And here I mentioned the workload is called as deployment, and this is where I'm telling how many replications I want. I can even say 5 replications I want, or 15 replications of the same container I want. And there are a couple of other information, key pair value information is available for you, labels and uh, other things, namespaces as well. This is the namespace, and this is the image which I'm running. So a couple of information which you can provide, which image you are running. And then there is resource information, utilization of resources, and container ports and other things. So this is the it's a kind of a service attached to it. The accessibility of this, so basically I'm opening up this particular way to access the information which will be deployed. So this is how you can write an object model. So you are telling the Kubernetes master that I want this information. This is the how I want the infrastructure to behave, and this is how I want to run it. And Kubernetes takes this information and it just executes it. So let us go and deploy this. I just want to show you. So I've already created a cluster. So that we don't really have to wait for the cluster to be created. And there is already cluster running. And there are a couple of things you can see here. You can uh, you can see there is how you communicate, especially from a community specific. There are namespaces, workloads, which is nothing but the deployment which I talked about. And then there is namespaces, which is more from how you can logically divide your Kubernetes cluster into different services, and how you can use services and ingress. You can take a look at this. Let me go ahead and deploy the code. Before I deploy, I'll just open the CLI, and let me do the CLI create to the storage. So this is how you can do. There is a Cloud Shell which is already there in Azure. So click on the Cloud Shell and you can access the shell from the browser itself. So let me, oops. Okay, it is getting created. While it does, let me copy the code. Okay, so Cloud Shell, everything available, already installed. Docker, everything is already installed. Python installed, so it's pretty easy to use. And so let me go and say, what was that? Azure -oat dot YAML. So I'll just create that and then open that file to insert, and I'm inserting. Did I insert it properly? Yep. Okay, I'm saving that file. So now it is available here. But even before I do it, I don't have an access to the cluster. So to get the access to the cluster, I need to run a CLI command of Azure to make sure that I get access to the cluster. This is the command. It is asking for the credentials from the Cloud Shell itself. So I'm just running this after an authentication. So it is now available to me. And so what we can do is just go and see, can I get node? So you can see a couple of services which is there at the top as well, just to give you. So this is the two different node worker nodes I had created. as an example when I showed you, right, how to create it while doing the demo for the Kubernetes cluster creation in AKS. So I'll just go ahead and apply this, just apply. So the what I'm trying to do here is I have declared I have declared the state what I'm looking at, and I'm just telling the Kubernetes master that, hey, this is how I want my infrastructure to behave, and this is a command to do it. And through this specific kubectl CLI interface, I'm doing that. And once I do that, it deploys uh, the containers and service, and it opens the service to access it. And this is how you can just tell the Kubernetes cluster, and it gets deployed. And see that as a developer, or as a as a DevOps engineer, I just need to tell in that I need to write the right set of YAML and tell Kubernetes, hey, go and manage my infrastructure, and your infrastructure is just available for you to access it and get your application running, and it's easy for you to manage, and it scales and it doesn't go down, because if one of the replications dies, it makes sure that replica sets create the another pod. So it's basically a pod level design. So one pod dies, the other pod comes up. So that's how this whole community is maintained self-healing, right? So that is one. So let us go and access this external IP and see that this application is up or not. So it's these are commands. So this is just talking to the API server which I showed you, and getting the information from the xhead. So all we did was we wrote a YAML file, handed over to the master. Master internally gives it to control manager. Control manager takes it and tells the scheduler to plan the deployment or plan the rollout of this particular desired state. And scheduler plans it using xset, and then it takes it and uses kubelets in the worker nodes which we created to make sure that it deploys these containers through a pod, and it is getting deployed. And kubeproxy is allowing us to access this application through an API address which we mentioned, and through a service concept, right? So this is the application which got deployed. And basically you can tell me you're a cat person or a dog person. You can also access this IP and actually tell me. So I can, this is how the application running at the Kubernetes level, and you can reset it and other stuff. So let me go back to my slide. So all the information I just provided is there in this specific PDF. This is a PDF. Basically, you can download this PDF while going to this link, and you'll get all the content. It looks like this. So how you can learn from each one, and it has link to those the specific activities or specific learning path. So it's day one and day two. These are the video playlist is available, and you can also access it from here directly. And there are core concepts which you can understand how AKS, or it's not just AKS, it's basically from a community specific how it runs and executes. And there is training webinar series available, and it's kind of getting complicated on different dates, right? The more you read about it on different days, you will go into the understanding of becoming an advanced Kubernetes user, right? So you will understand how to build microservice applications. Distributed system book is there, wonderful book to understand how to build a distributed system and manage it. And then there are a couple of other details here. This is a resource which I just wanted to give you so that you can uh, go ahead and learn stuff and get started with Kubernetes. and that's the uh, that's what I wanted. Um, yeah, what is it? Okay, so this is the link to it. Okay, so that's one thing, and thank you. And any questions